Hello everyone. Um, I'm Sai Venkatakrishnan, a PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So this is week 2 session for the course Introduction to Haskell Programming. Okay. So the agenda of these live sessions would be if you have any queries pertaining to the week 2 lectures, all the assignment questions that you have completed, all the practice assignment questions, if anything, you can unmute yourself and ask the question or post it in the chat box. So any specific questions you want to and you want me to answer first pertaining to the week 2 lectures? Week 2 question 3. Question 3 in the actual assignment or the practice assignment? Okay, the main assignment. Right. So, any other questions apart from Sagar's question in the assignment? Okay. So, in that case, yeah. So, in that case, what I do is I will. Okay, week 1 question 5, week 2 question 1 and 2, right? So here actually I have week 2 the practice questions as well as the main assignment questions amounting to around 9 or 10 questions. So we'll first discuss week 2 assignment questions and then we'll move to week 1. Is that okay?
Yes, sir.
Okay, cool. So this is week 1 practice questions, week 2 practice questions, I guess. Yeah. So let's start from this. So the question is, suppose we have L1 and L2. Two lists are defined as follows. So this is the first list and this is the second list. So what's the value of L1 equal to L2? So here, as much as possible, I'll try to do like instead of directly opening up the interpreter and just copy pasting the code snippet, right? I'll try to explain it by hand because in your examinations, the final exams, when you are attending, you won't have the interpreter uh, for your help. So you should understand the concept uh, thoroughly so that you can answer them without the help of the interpreter, right? So try practicing answering the questions uh, first using that approach, and then you can check with the interpreter whether you are correct or wrong, and if you are wrong, try to understand like where you went wrong and correct your approach, right? So in this question, first we'll see what L1 is, what the list 1 is evaluated to, right? So it's given L1 equal to filter of its upper A to Z, right? Now this filter is a function on list, as you have seen in the week 2 lecture, the video lectures, function on list. And what the filter function does, it takes a function, right? It takes a function. So the type signature for this filter function would be as follows. It takes a function which is takes some takes each element of the list, right? Takes each element, takes an element and returns a boolean value. Okay, it takes the first argument as a function, and that function signature would be taking one element and returns a boolean argument, and then it takes a list of elements followed by it returns another filtered list. So this is the signature of the filter function. Okay, so corresponding to this, what we see is the function is upper corresponds to this, the first argument which is to be passed to the filter function, and this list A to Z, all smaller case alphabets, characters. This is the list of characters being passed as a second argument. Now what the filter function does is, it applies this is upper function, it applies this upper function whatever was passed to the filter function on each element of the list. On each element of the on the list, this is upper function is applied, and only if it's true, right, that element of the list is returned back. If it's false, that element is deleted. Deleted as in it's not part of the list anymore. So in this, the condition is the function is upper is nothing but what all conditions will this function evaluate to prove. So if it's is upper of A, any capital letter character, right, uppercase character, it will be true, and this upper of any smaller case character, lowercase character, it will be false. Okay. Now, so only so by this logic, right, the output of this function filter of is upper A to Z is nothing but it filters out all the elements, all the characters in this list small a to small z. Only those characters which are all uppercase, those are only retained back because they only evaluate to true, and the remaining characters are all removed from the list which is returned back from the filter function. Okay, and unfortunately, like none of the characters in the list are uppercase, so everything evaluates to false. So the list returned by the filter function is actually an empty list. Okay, so L1 is of an empty list. So this is what L1 evaluates to. And second, uh, any doubts till this at the evaluation of list 1, the L1? Right, good. So now let's see what L2 evaluates to. Oops. So we have L2 equal to x 0 comma mod of x. Okay, so this is right. So this is actually the concept of list comprehension, right? So which is covered actually in week 3. But if you just so there's nothing but similar to the filter application, right? So the filter function. So basically it takes this list 0 to 10. So x is 0 comma 2 is to 10 means it is nothing but an arithmetic progression. So as I have seen in the video lectures, you can initialize the list in multiple ways. So in the previous the previous list we used A to Z, so it's nothing but A, B, C up till Z. All the characters, the 26 alphabets should be present as part of the list. So in the same way here for numbers, you can do you can form arithmetic progression. So here the all the even numbers 0, 2, 4, 6, 8, 10. So up till 10, all the even numbers is part of the list X. So now what list 2 evaluates to is it has this, it should all the elements of x which satisfies this specific condition odd of x. So odd of x is nothing but if the if the element in a list, if the number is an odd number, it evaluates to true. Even number means it's false, right? So now this condition is applied to each element of the list x. So x is nothing but all even numbers 0, 2, 4, 6, 8, 10. And when we apply odd, um, so when we apply odd to this specific list over here, we get an empty list, right? Because here all are even numbers and none of them are odd, so basically it is sort of all the elements are sort of filtered out. Okay, so that's what happens. So L2 is equal to an empty list, right? So we got both L1 as an empty list and L2 also as an empty list. And now what the question is, what's the value of L1 equal to L2? So seeing both are empty list, you would be assuming it to be true actually, but this is wrong. Okay, so this is wrong because if you notice carefully, Haskell is sort of like strongly typed language, and by strongly typed is the type for each variable is in every statement is associated, it's computed properly at static time actually, and if there is any type error or something, right, it's usually thrown as an error at compile time itself. Your program won't compile at all in the first place, right? So here both are empty list, and what's the uh, why it's a type error, you might wonder. The reason being, if you notice at the type signature of this filter function, right, this filter function is nothing but whatever is the input, whatever is the type of the input list, it returns a list of that specific type. Okay, so here it takes a list of characters. So here this A is actually substituted for character. Okay, so now the output of a filter function, the Haskell interpreter or the compiler will check whether the will associate the output of the filter function to this type only, which is character, list of characters. So your empty string, even though it's empty, it assumes it to be a list of characters, right? So this is assumed to be a list of characters. In a similar way, when we evaluate L2, right, you get the initial list on which you are operating. That's a list of integers actually, or list of numbers actually, list of integers or numbers, right? And even though finally on applying the odd condition on every element of the list, you get a uh, empty list, but that empty list is actually an empty list of integers, right? So now when we check for equality L1 equal to L2, this will not result in true nor it will result in false, right? But instead it will result in a type error. The reason being, since Haskell is strongly typed language, any operation between two types or two different types, right? This say like A plus character A plus 2 or something, right? This will fail in Haskell. It won't work because this is of type character and this is of type integer. So both of these will fail. It won't result in some garbage value or nothing. Instead, it will just stop compiling, it will throw out a compilation error saying it's a type error. So that's why we mean Haskell is a strongly typed language. Haskell is a strongly typed language statically. So at the compile time itself, it catches all of these errors, right? Okay. Um so the key point you should note is what the filter function does and how the list is computed, right? So say now the other way to think about this, like instead of this is upper function, right? If you give say is lower or something like that. So instead of is upper, say if you give is lower or something like that, it will return it will return the same list as it is, because all the characters are lowercase and it fits the condition. It's true for all the elements and it returns the same list, small a to small z. Now what would be the type of L1? It will be since it's all characters, it is a type of, it's a list of characters, right? Now, usually, like just by changing this condition, right, the function which is being passed to filter is upper or is lower, you cannot change the type of the result. Whatever is getting returned from the filter function would not change. It should be standard, right? So that is one way to think about. Even though it's an empty list, if we pass the is upper function, uh, just think about what if we pass a condition or a function which is sort of returns back the original list. So that type, whatever is returned back, is the one which is also associated with an empty list, which is a list of characters. The same way you can think about the second list also. So instead of odd of x, if we had even of x, what would have happened is it would have returned back the same list of integers 0, 2, 4, 6, 8, 10, right? So this is the way like we should think, and even though both are an empty list, the way we should look at this um, empty list is we should associate the type also along with it in any operation we do, right? And why this is important is because say in a later operation or in a later function call, when I pass L2 to some function where it is expecting a list of characters, it will fail in that scenario if I allow it over here. Or if I pass L1 to a function where it's expecting a list of integers, it will fail over there, right? So someone had posted a query like it has type defined or Haskell defined the type. Right. Okay. So you are asking whether it has the type defined already, like oh, like who defines the type for L1 or L2, right? Right. So the the type of L1 or L2, that's a good question. So so there's something called sort of like type inference. So this sort of like we'll cover this in later lectures in detail. But usually, what happens in lists in these functions working on list, right? You will have different types of list. As in, like you will have a list of integers. You will have a list of characters. That is a string actually. So you will have a list of strings. Hello, and you will it's not a list of string. You will have a string actually. That's it. Or you will have a list of tuples, right? So there are many types of list you can have, and some common operations on these list include the map function, and afterwards this filter function like that. So map is nothing but you apply a function on each element of the list and you get a new list. Say if you have like all a number of integers, a list of integers. If you want to add one to each integer element in the list, you can use a map function, right? If you want to filter out only the even numbers in a list of integers, you can use this filter function like that. So this map and filter function are sort of common operations on list, and if I want to implement these map and filter functions, right, it's sort of like what approach should I use to implement, right? So since Haskell is strongly typed, what will be the type of this map or filter function? So usually like if you write out any function, uh, if you write any function, say it takes two integers and returns back an integer, you will write it like int and int, right? It takes two integers and returns back an integer. But for a map and filter function, how will you define the type of that function? What type would the parameters it would expect, and what would be the result type? And so if you want to, you can have a map for every different type. So for map of for a list of integers, you can have a map underscore integer list. For a list of tuples, you can have map underscore tuples, right? But it would be like sort of infinite number of map implementations you should be writing, because you can have list of integers, or you can have like nested list up to so much, up to whatever level you want. And also if you want, you can have a list of tuples, and each element in the tuple can be a different one. So for each of those types, you should have a separate map function, and you should be calling that map function a separate map function, right? So this is sort of like very hectic, and it's not a proper way of developing. So what they do in Haskell is something like this, where they have a generic implementation of map filter. And since Haskell is strongly typed, if you notice this type signature, what I have written over here, this type signature over here, a bool list of a and list of a, right? This specific thing, right? So this is the type of filter function. So basically what it does is, I don't know what my what type of list the filter function is applied to, but but whatever the type of list the filter function is applied to, right? Say when at that specific execution point, if I'm applying a filter function to a list of integers, my Haskell compiler will ensure that my result will should also be the same list of integers. And that's why you have this. So what they use over here is something called as type parameters, right? So basically this small a over here, it acts as a placeholder for any type, right? So if I pass a list of characters, this a is nothing but a character. If I pass a list of integers, it is nothing but an integer. So whatever list I am passing, if I pass a list of tuples where the first element is an integer and the second element is a character, the type becomes a int comma character, right? So like this, the a is sort of a placeholder, and this is filled in at each line of the execution. So in the first statement, if it's like L1 equal to filter, at that place filter would be the type signature of filter would be replaced with a would be replaced by character. Whereas in a later stage, if you are using some other list, but instead of list of characters, you are passing a list of tuples, there the placeholder a would be replaced with that specific tuple type, int comma character or something like that. So at each execution point, your placeholder array would be replaced, and the the type is inferred. Actually, the type is inferred by looking at the arguments which are being passed. So here I am passing the list of characters. So based on that, the type is inferred by the compiler, and the specific type signature, which is sort of generic, which applies to any type or any list of types, right? This becomes concrete. This becomes concrete, and all these A are replaced by that specific type, and Haskell checks whether that type is correct or not, and all the function type matches the is upper function type, and then it attributes that type to the result which is passed. Like this is actually polymorphism. Uh, it supports multiple types in a safe way, actually. So any doubts in question 1? Okay. Okay, so for this upper won't work in the command line, you should use import data dot character. This sort of like a module. So you should use that statement in the interpreter first, and it will load that module, and there you will have all these functions related to characters. Okay. So any doubts in question 1? Okay, cool. Thanks, madam. Um, data dot. Okay, I have not tried that specific thing. Will data dot cal dot is up. I guess we should load the module. We can try at the end of this discussing the assignment questions. We'll see whether that works in the interpreter. Right? Data dot cal dot is up directly instead of loading the module. Cool. So in that case, let's move on to the second question. So what's the value of f defined below? So here f is nothing but they are defining it to be a tuple. F is a tuple, and it has two elements. The first element is a list, right, and the second element is an integer because it's the length of the list, right? So here, so basically it is of type. Um, so this floating point, so I guess it's float, right? And length is an integer. So this is the type of f, and now they want to find out what the f value is. So here you have this var condition, the var statement, and this L is evaluated to this. So this is also some sort of arithmetic progression, but in the descending order. So you see that the first two elements are 32 and 28.3. So 32 minus 28.3 is 2.7, is it? No, 3.7. Right, 3.7. So this is what the difference should be between consecutive elements, and this sort of CD should go up till 1. So list L is now actually 32.28.3, and then again subtract 3.7, you will get 20. 4.6, and then some number, right? Just you can do your calculation. It's pretty easy. And up till whatever the highest number larger than 1, the least number which is larger than 1, up till that number this list to be evaluated to, right? Say assume it's like 1.2 or something, I'm not sure, so just assume it's like up till 1. Okay, and this is your list. And now so this will be the first element of f. So this will be the first element of f, and the second element of f would be the length of this list. How many elements are there? It starts from 1, 2, and so assume it to be 13, right? So this is the second element of list. Sorry, the second element of f. So now f is nothing but this list over here, 32, 28.3 up till 1, comma 13, assuming it to be the length, right? So this is what f evaluates to. And in the tuples, first and second are sort of like common functions, right? So first is nothing but it takes it returns back the first element of a tuple, and second returns back the second element of a tuple. So any doubts in this second question? It's pretty straightforward. Right. Okay. Thanks for pointing that out. So basically, um, so in Haskell you have a float, integers, right? So float is like floating point numbers. Integers are like non-floating point numbers, but what's it? Whole numbers and all the negative numbers all included, right? But they are not floating point. So here, since we have 28.3, right? It's not list of integers, list of floats actually. And by default, if you see a number 32, right, it is a type of integer. To identify explicitly it as a type of float, Haskell, while displaying it, it will display as 32.0. So that's not it, just to denote that it's all a type of float only. So yeah, since it's a list of floats, it acts that floating point thing, point 0 as compulsory while displaying the list. Oh, okay. The answer string showed wrong. So in the answer, it wasn't expecting this point 0, is it? Is that the case, Tyagarajan? Right. So in that case, I suggest you can post this question on the forum. The TA in charge will definitely reply back. Because this might become an issue in your final exam. Some might add this point 0, some might not include that. Both should be correct actually. Or so this sort of like you can post it on the forum. Right, cool. Okay, so in that case, let's move on to the third question. Okay, so given below is an incomplete definition for the function take. Now complete the code by fill in the blanks. We have okay. So we all have first we should understand what the take function does. So if you have a list of elements, starting from the index, if you have a list of elements, right? Say this the length of list is 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, right? and if you say take of 2 comma l, right, if you say take of 2 comma l, it will take the first two elements of the list. It will return, it will split the list, and it will return back this as the output. Okay, so the type signature for take is as follows. It will take a integer, it will take an integer which corresponds to this specific n over here, and then it will take a list of elements of any type, and it will return back a list of elements of that same type. This is what is the signature for the take function. And what's the logic is, whatever number is specified in this integer, the first n elements of the list is alone returned back as the result. The remaining elements are discarded, it's not returned back. It is sort of like a subset of the list. Okay, um, this is what a take function should do. And now it's given we should implement the take function by filling in this blank. So you have the implementation as follows. The given implementation, you have take of n l, where if n is less than or equal to 0, or it's an empty list, then you return back an empty list. Otherwise, what? Okay, so this is what the question is. Now this base condition is pretty simple, which they have given already, which is if you have taken all the elements, which, so if n is equal to 0, or if it's a negative number, that is if n is equal to 0 means you don't want any element of the list, right? Or if it's a negative number, also in the same way, it's sort of undefined, the argument. And if you are an empty list, right, then there is no sense in taking the first element of the list because the list is empty. So in all these cases, you return just the empty list. So this is the base condition, and this it's already given. Now otherwise, is the case where it's a non-empty list where there's at least one element, right, and n is greater than 0. We have both of these true. So n is greater than 0, that's true, and it's a non-empty list. Now you should fill in this blank. So take of 2 comma l. So basically, in functional programming language, your go-to um, program construct should be recursive functions. So usually in C or C++, any simple code if you want to write, you will be using looping construct like for loop or something like that, right? But in functional programming languages, your go-to construct, the programming construct should be recursions. So the reason being, in a looping construct, you usually mutate your values, right? So when you keep on um, when you keep on implementing, like iterating your loop, right? Your loop condition and everything should be checked in every iteration of the loop, and by that, basically your state should be carried forward. Whatever your the condition, whatever you are checking, right, it should be maintained throughout the execution of the loop, and your value should all be mutable, as in it's the same value that you are operating on throughout the iteration of the loop, and you are checking the condition of that value. Whereas in functional programming language, the core concept is basically it is sort of functions which are working on immutable values, and the programming construct which gels with that concept is recursion. Function calling it again and again, and all the arguments which are or the state which has to be maintained, everything is passed as arguments, that's it. And you don't mutate or change the state of a value of that same value. Instead you work on different values actually. You don't change the same value again, right? So that's what is all about functional programming languages like Haskell. So here also you have to see like you have to come up with a logic in terms of this recursive idea. Think in those terms, right? So for an empty list you have this condition, base condition, which is already given, and for a non-empty list you will have you should fill in the blanks. Now how you should start approaching this is assume you just have a one element list, right? So you just have one element. So what will you be doing? So you and assume n should be 1 or something like that. Okay. So in that case, n to be greater than 0, right? And you just have a one element list. In that case, what would be this blank filled up? It will just be that element within that list. It will just be the list itself, right? So if it's just a one element list, whatever list you are getting, you would return back. Okay. But if it's a two element list, and if n is equal to 1, and if it's a two element list, say 3 comma 4, right, then you should just return back, the answer should just be 3. So now what you should do, you should just return back this 3 alone, and this 3 is nothing but actually if you take the so this sort of like, and if it's sort of like n equal to 2 and you have a 3 comma 4, you should return back again the whole list. So all these sort of conditions should be working in this solution whatever you provide in the blanks, right? So the answer, what the solution is for any non-empty list, right? You start from n which is greater than 0, you take one element of the list and again call the take function. So you sort of like repeatedly apply the take function on the remainder of the list after removing the head of the list, and you decrement the n in each call of the take function. So basically what the logic would look like is, if say you have n equal to for uh, for n equal to 2, and if you have a list like 3, 4 and 5, right? If you have a list like 3, 4 and 5, you should call the take function again and again. That's what like recursion is all about. It's sort of like a loop, but it's sort of more like clearer, precise, and you have this base condition and this recursive condition. So the recursive condition is, you take just n equal to 2 means it should take the first element and the second element. So what you should do is you take the first element alone, right, and call take again, but this time you should not pass this first element to take. Instead you should pass only the remainder of the list. Okay, and n should not be passed as 2 which you got initially. Instead you should decrement 1 because you have already taken one element of the list and there is just one more element to take, right? So you repeatedly take oops, sorry. So you repeatedly take one element from the list in each call to take, and finally and finally in the second call, right, this n would be 1 and you will be having 4 comma 5, and when this, you will take this fourth element and you will decrement n again, as in you will call take again, and you will pass 0 and this remaining element 5. and since 0 is sort of base condition, it will return back an empty list and it won't return back this list with element 5. Okay, so this is what the logic of take should look like, and the solution to that is, so basically what you should do is, if n is greater than 0, it assumes that at least one element would be included in the list, that is, at least the head of the list would be included in the answer which is returned back. So I will use the head function, which takes the which is like predefined. It takes the head of the list. So I take this and I will concat this head of the list with whatever is the remaining list which you get from the take function. Okay, so this is what the answer would look like. So basically this is what we had discussed. So if n is greater than 0, then for sure I am confident that the head of the list would be included in the result. So that's the first element. So I have included this head of the list. But now the remaining elements, whether they are included or not, I am not sure, because it depends on the n value. So what I do, I again pass n minus 1. I again invoke take function, but this time what I do, I don't pass the whole list again. Since I have taken already an element from the list, I decrement n, so I pass n minus 1, and I pass the remainder of the list, which is tail of L. And now again it calls the take function, and if it's an empty list, it will return back the empty list. Or else, if again n is greater than 0, right, then again you have the you can be sure that whatever is the head of this remaining list, right, that will be included in my answer. So I take the head out and pass the remaining tail and decrement again n by 1, and again invoke take function. So basically until n becomes 0, all the list is emptied out. Until then you will be calling take again and again until your list is constructed. So this is the answer. So this sort of like so this sort of, if you see it in this way, right, if n is greater than 0, which element is assured to be in the list, given it's a non-empty list, that's the head of the list. For sure it will be there in your answer. So you include that, you take out that element from the list. And what elements would be present in the answer which is returned from this take function from the remaining list, that you are not sure. So again you pass invoke take function and you pass n minus 1 and the tail of the list. And by just invoking that take function again, right, everything falls into place. So this is the beauty of recursive function. You just have to find out this base condition, and you have to find out when n greater than 0, you have to find out this condition which is sort of like true for all cases, and then it sort of all falls in place. So any doubt in this implementation? Okay, cool. So in that case, let's move to the actual questions uh, of week 2. So it's given this list, right? What's the type of this list? So you have your and then you have and then this, right? So it's nothing but your and is this and operator, and less than is the less than operator, and all these are infix operators. And basically your infix operators are sort of like applied infix, right? So usually when you in my previous week's live session, I would have explained that these infix operators are sort of like special functions or infix functions, right? They're evaluation is sort of like placed in fix. So usually when you apply a function, say f of x, right? So you have the function name in the prefix position, and then you all the arguments that you want to pass, you then write it over here. So x1, x2, x3, like that. So these are all the arguments. Whereas infix functions are like special functions where your operator is placed in between. So 2 plus 3 or 2 minus 3. So this plus is an infix operator, and you have a function associated with this plus, and this function is nothing but plus within parentheses, and for this minus it's nothing but this minus, and for 2 by 3, right, there is this function, uh, the slash function. So any infix operator that you are using can be converted into this function by just enclosing it within parentheses. And what's the use is, so instead of giving 2 plus 3, right, I can give plus 2 and 3. So this is sort of like similar to this. You have the function name followed by list of arguments. So in the same way, if you give 2, 3, it will be like 2 divided by 3 only. So the answer should be the same. Okay, so this is what they have provided in this list. So this list is nothing but a list of functions actually.